We did this question several days ago. The lowest common ancestor of DPC lives. For this question, to give us a tree with which is called root, find the lowest common ancestor of the leaves. The define our lowest common ancestor of ancestor of is a set of nodes. Is a node A with the largest depth such that every node in S is subset of root A. For example, 7, 4. So the lowest common ancestor is 2. And also we mentioned that if there is another one, for example, 9, right? So this is depth 3. This is also depth 3. We need to have a node cover all of the depth node cover this, and this. So lowest common ancestor is this. Last time what we did is that we use divide conquer, and we trying to find the left depth and the right depth. If left depth equals the right depth, then return the root. If the left is depth is greater than right, we recursively call this function again to get lowest common ancestor. So that, and if the left depth is smaller than right depth, we also call this function for the right child. The problem is that from the top down, we calculate the depth multiple times, so it will be not be an O(n) time complexity. So because there are multiple calculations, so what we do is that we add a memo for every node to store its depth, and so that and in that case we get O(n) time complexity. Today we are going to do another approach for this question, is that we're trying to do from the bottom up. That is the post trade traversal. We know post trade traversal is the left right root, right? Left right in the root. And for each node, we return a result passing its depth. We return a result which will have two parameters. One is depth, another is its common ancestor. And if on the left the depth equals right, then we return a new result and with root. If left is greater, then the left result common ancestor is passed back to its parents, and and vice versa. If right depth is greater than left, then this one's lowest common ancestor is passed to its parents. So that we just from bottom up, we just do the post trade traversal, and every node will also be calculated once. So let's write code for this. We are going to use a class called a result, and we are going to have an int depth, and also have a tree node for comma. And we are going to have a result because DFS root in the return result.com. So let's write the result DFS functions. This DFS we're going to return the result. new result. And I don't know. Okay. And let's have a result. Left result equals DFS node dot left. And the result, right result equals DFS node dot right. And let's try to get its left depth. Equals left result of depth. And right depth equals right result of depth. So if left depth equals right depth, return new result, and we'll have left depth plus 1, and will be node. So let's say if left depth greater than right depth, we are going to return new result, left depth plus 1 in the left result, comma. And otherwise, that is the right depth greater than depth, just return new result, right depth plus 1, right result, comma. Yeah, right this way, the time complexity is also O(n), because every node we just calculate once, and we pass the result bottom up to its parents.